Okay, so here we have our CBA 3 review. Alright, this is coming up soon, so I'm going to do my best to go over this the best way that I can. I know that we went over this in class, and we also went over some of these questions, excuse me, in for our Saturday Academy. So let's go ahead and jump right into it. It says number one, if potatoes cost $1.75 per pound, what is the total cost of 2.5 pounds of potatoes? Okay. So basically we're gonna buy 2.5 pounds worth of potatoes, and each pound costs $1.75 per pound. So how I'm gonna set this up is I'm gonna set it up as 1.75 times 2.5. Now I'm setting it up like this for a reason. It's to identify and visualize how many digits are on the right side of our decimal. So we have 1, 2, 3. And that's going to come into play later when we actually multiply, because when we multiply, all we're going to do is stack our multiplication and ignore the decimals for now. When we get our final product, we'll swing that decimal over 3 times because we have 3 digits behind the decimal. Okay, so 5 times 5 is 25. 5 down, carry the 2. 5 times 7 is 35 plus 2 is 37. 3 times 5 is 5 plus 3 is 8. Put a 0 here, cross that out, cross that, scratch that. We have 2 times 5, which is 10, 0, carry the 1. 2 times 7, which is 14, plus 1 is 15, carry the 1. 2 times 1 plus 1, which is 3, and we'll add our partial products. We get 5, 7, 13, and 4. And then we're going to swing that decimal over 1, 2, 3. So really what we have here is $4.37. But you're going to notice that our answer choices don't really have that. When this takes place, okay, when this happens, you look at your, I guess, the number furthest behind. Look at your last number in this case, okay? There's a rule here where if it's 4 or less, you let it rest. If it's 5 or more, you add 1 more. So that's what we're going to do, okay? We're going to rewrite this as 4375. Because it's 5 or more, we add 1 more there. So what we have here is $4.38, which means our answer in this particular case would be A. Okay, let's move on to number 2. Number 2, it says Martha walks at a rate of 1.5 miles per hour. If she walks for 3/4 of an hour, how many miles will she walk? Okay, so what we're going to have to do here is we're going to have to multiply these numbers together. A good way to set it up is to turn our fraction into a decimal. So in case you didn't know, 3/4 is the same as 0.75, but I'll just show you how we get that here. So 4 can't go into 3, 0, decimal, 0. 4 can go into 30 7 times, that gives you 28. That's a 2, another 0, bring it down, and it goes into 25 times. So 3/4 is 0.75. Now that's important because when I set up my multiplication here, again, I'm setting this up so that I can see how many digits are on the right of my decimal. There's 1, there's 2, and there's 3. That's going to be important when we get to the actual answer. So here, now all we're going to do is ignore our decimals and multiply 15 by 75. So 5 times 5 is 25. Put your 5 down, carry your 2. 5 times 1 is 5, plus 2 is 7. Put my 0, cross out my 5, and scratch out the number I carried. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. I have a 5, I have a 12, I have a 1, and I have a 1. And then I'm going to move my decimal over 3 times. 1, 2, 3. Just like that. So my answer here is H. Alright, looking at number 3. It says, if 6 tomatoes costs $5.88, what is the cost of 1 tomato? Alright, so we're just going to get our final cost of $5.88. And we're going to divide it by the 6 tomatoes that we bought so we can find out exactly what the cost of just 1 tomato is. Okay, so we're not thinking of when we divide by our decimals, we kind of ignore the decimal that's going to come into play at the end. So we're not thinking about how many times can 6 fit inside of 5. We're thinking about how many times 6 can fit inside of 58. Okay. So 6 times 8 gives you 48. 6 times 7, 6 times 9 will give you 54. So 6 times 9 gives you 54. 8 minus 4 is 4. And when you bring down your 8, we know that 6 can also go into 48. 8 times. We have nothing left. We bring this decimal up. And the cost of 1 tomato is going to be 98 cents. Alright. For this one's relatively simple as well because you don't have to solve anything. They just want to know which expression is equivalent to 8 divided by 1 and 3/5. So, couple things we have to do here, okay? We'll keep our 8 by itself, I guess. I mean, it's always over 1, but it doesn't really matter here. We'll change our division sign to a multiplication sign. But before we can do anything here, well, what we have to do here is turn this mixed number into an improper fraction. So let's go ahead and do that. And we'll do that with our walk around Texas technique. So here we go. We're going to walk around Texas. 5 times 1 is 5, plus 3 is 8. 8 over 5. So this is what? 8 over 5. But remember, we have to flip that. Okay, this is where we have our K, C, F. We keep, we change. If this is what this becomes, we need to flip that. So instead of 8 over 5, we should have 5 over 8. Now it's just a matter of matching it up. This is really 8 over 1. So 1 over 8 is not going to work. I'm not sure why our 5/8 would come first. That's not the first fraction. 8, almost. This is still 8 over 5, so they hadn't flipped the second fraction yet to find the reciprocal. And this looks like our match here is going to be J. All right, next page. Okay, so here, this is going to be interesting. It says, in the expression shown, x represents a rational number, and all of our answer choices are rational numbers, even the 2. Remember, the whole number is still just a number over 1, which makes it a fraction. Here it says, what value of x makes the expression equal a number less than 5? Okay, so we are looking for a number less than 5. And in order to find this number less than 5, we're going to have to set up a few different things here. Okay. So, I'm going to have 5 parentheses, 5 parentheses, 5 parentheses, and 5 parentheses. So the reason why I have those parentheses set up is because in order to find out which of these answer choices equal a number less than 5, I have to replace this x, this variable, with these numbers. I have to, or else it's not going to make any sense. So let's go ahead and do it. I know that 5, so here I'm just going to multiply straight across. This is going to give me 5/9. Well, 5/9 is a number less than 5 because I don't even have one whole number. I need 9 pieces, but I only have 5. So far, A is looking good. We'll come back to it. Let's go ahead and go to B. Okay, before I can do anything here, I have to turn this mixed number into an improper fraction. So let's do that real quick. 1 times 2 is 1, or 1 times 2 is 2, plus 1 is 3. So now I have 3 over 2, and I cross multiply. That's going to give me 15 over 2, and of course 15 over 2 is going to be 7 1/2. So this is really 7 1/2, which is clearly not a number less than 5, so I know I can't say it's B. Alright, I'm going to plug in my 2 right here. That's just going to give me 10. 10 is also not less than 5, so that is not going to work. For D, I'm going to plug in 11 over 10 over 1. Before I cross multiply, I can identify common factors. There are no common factors between 1 and 11, but there is a common factor between 5 and 10. 5 goes into itself once, and it goes into 10 twice. So now I have 11 over 2, which is going to be, what do I have? 5, 10, 1 decimal, 5.5. And 5.5 is not a number less than 5. Therefore, my only answer choice is going to be A. Now that one's a little tricky because we haven't really done it yet, but all you're doing is you're replacing the x with the numbers that they've given you in order to see if the statement is true. That's all. Okay? Let's go to number 6. It says, which of the following statements is not correct? Not correct. So we're looking for the incorrect answer only. We'll see if we can find it. Now it says the product of the product of the product of the product of. So we're going to be multiplying here. We only really have to do multiply once. The biggest thing that we're going to be paying attention to here is that they're saying the product is less than 7, the product is greater than 7, greater than 3/4, and between 3/4 and 7. So that's what we're going to have to look like, or look for rather, after we actually do the multiplication. So the product of 7 and 3/4, we should end up with 21/4, which when we divide should give us 5 and 1/4. So we'll do this. 2, 8, 2, 0, bring it down, 5, no remainders. Okay, so 21/4 is the same as 5 and 1/4, or 5 and 1/4, aka 5/25. So let's see which one is not correct. Based on what we just solved, F is saying that the product is less than 7. Well, that's true, so I can't pick that. Here it's saying the product of 7 and 3/4 is greater than 7. We just solved this. Is 5/25 or 5.25 and 5 or 5 and 1/4 greater than 7? No, obviously not. So this should be our answer here. Is it greater than 3/4? Yes, and that's why we can't pick it, because again they're asking for what's not correct. They're saying it's between 3/4 and 7. Well, that is between 3/4 and 7, so we can't pick it again because they're asking for what's not correct, and all three of those statements outside of G are correct. All right. Number 7, it says Eli's paycheck before taxes is $198.65. If he worked 27.4 hours, how much is Eli paid per hour? Okay, so we're going to take 198.65 and we're going to divide it by 27.4. Now there is a little trick that we do here in order to make our numbers, or our divisors that end up being decimals, to actually turn those into whole numbers. Okay, the easiest way to do that is just to get the decimal, and it's as if you're multiplying it by 10, so you're just moving that decimal all the way to the right. So now it's, instead of 27.4, it's just 274. And here we're going to scoot that one over too. And so now instead of 198.65, it's actually 1,986.5. So yeah, there's a pretty big difference there. So this is where we're going to make a list. Okay, it's going to be a fairly long... Well, it's going to be a list we're not necessarily used to. I'm not going to say it's going to be a long list, but it's a list we're not necessarily used to, because now we need to think in terms of 274s, and we don't usually count in those types of increments. So let's go ahead and do it. So we'll start with 274. The next number should be 548. Let's see, after that, it's going to be 822. And then we're going to have 1,096. And then we're going to have 1,370. I think I'll do one more. And that'll bring us to 1,644. And that's us basically skip counting by 274 a bunch of times. Let's do it one more time. Next one will be 1,918. So, now, let's see what we can do. How many times can 274 fit inside of 1,986? Well, now that we've done this math, we know it can fit 1, 2, 3, 4, 5, 6, 7 times. Okay? So I'm going to put my 7 up here. And that's going to give me my 1,100 or 918. And then we will subtract. I can't take 8 from 6, so I must go next door and borrow. That's a 16. 16 minus 8 is 8. 7 minus 1 is 6. And I bring down my 5. Now, how many times can 274 go inside of 685? It looks like twice is our only answer here, which is okay. We'll end up with 548. Now again, we can't take 8 from 5, so we have to go next door and borrow. 15 minus 8 will give me 7. 7 minus 4 will give me, what, 3. And then 6 minus 5 is 1. I'm going to put a 0 here and bring it all the way down. Haha. 274 can be multiplied into 1,370 evenly. 1, 2, 3, 4, 5 times. And I bring my decimal up. So how much does Eli get paid per hour? Well, Eli makes $7.25 per hour. Alright, let's keep on keeping on. Okay, here it says Tanisha's tutoring lesson is 2.5 hours. Yesterday she had a ballet show and she missed 1/4 of her tutoring lesson. How many tutoring hours did she miss during her ballet show? Express your answer in the simplest form. Sorry, show your work. Okay. All right. So here we have 2.5. Basically times 1/4. So, all right. We can do that. We can do 2.5 times 1/4. All right. In order to do to multiply or divide a mixed number, we have to convert this so we can walk around Texas here. 2 times 2 is 4. 4 plus 1 is 5. 5 over 2. And we multiply straight across. Here, we should end up with 5 over 8, which can't be any further simplified. So 5/8 is how much of her tutoring hours that Tanisha missed. For 9, it says the recipe calls for 9.5 cups of flour to make a batch of cookies. How many batches of cookies can be made if you have 38 cups of flour? Okay. So we're actually going to start with our 38 cups of flour. Awesome. In order to multiply or divide mixed numbers, you have to turn them into improper fractions. So that's what we're going to do here. So now we have 38 over 1 divided by 2 times 8, or 9 is 18. 18 plus 1 is 19. 19 over 2. But this is where I'm going to use my KCF strategy. And that's where I keep, change, flip. I'm going to keep my first fraction, which is going to be my 38 over my 1 here. I'm going to change my division symbol into a multiplication symbol. And I'm going to flip my 19 over 2 to 2 over 19. Now, there is actually a common factor here. It's not in our 1 or our 2. It's in our 19 and our 38. 19 can fit into itself once, but it can also fit into 38 twice. So when we multiply straight across, we should end up with 4 over 1 or just 4. So she can make 4 batches of cookies. Well, whoever's making them can make 4 batches of cookies. Alright, let's keep going. Here we have Hank. So Hank earns $7.25 an hour. If he works 4 hours each week, how much money will Hank earn in 1 week? Okay, cool. So again, I'm going to set it up like this so that I can see visually how many digits are on the right side of my decimal. Here I see that I have 1, 2, 3. Then it's just a matter of setting it up and solving. So I'm going to have 725 times 224. Let's go ahead and solve. 4 times 5 is 20. Put your 0 down, carry your 2. 4 times 2 is 8, plus 2 is 10. 0 down, carry your 1. 4 times 7 is 28, plus 1 is 29. 0, cross out, scratch, scratch. 2 times 5 is 10. Put your 0 down, carry your 1. 2 times 2 is 4, plus 1 is 5. 2 times 7 is 14. Cross that out, scratch that, put 2 zeros down. 2 times 5 is 10. Put my 0 down, carry my 1. 2 times 2 is 4, plus 1 is 5. And 2 times 7 is 14. And I add my partial products. I should get 0, 0, 14, 9, 10, 12, 6, and 1. And then what I'll do is I'll scoot my decimal over. 1, 2, 3. So in that 1 week, Hank should be making $162.40. For number 11 is so Rebecca bought, I'll say 1.5 pounds of grapes, and that cost her $3.72. So we really want to find out what the cost of 1 pound was. So let's go ahead and do that. We're going to take our total cost of $3.72 and divide it by the amount of grapes we got, right? Which is represented here in our 1.5 pounds. Now again, we have to turn our 1.5, our divisor, into a whole number. And in order to do that, we're going to multiply it by 10 and scoot our decimal over. But what we do to our divisor, we must do to our dividend. So now we have increments of 15 instead of increments of 1.5. It's a little bit easier for us anyway. So we'll make a small list of 15s, 15, 30, 45, 60, 75, 90, 105, 120, right? Cool. So 15 can fit inside of 37 twice. So that'll give us 30. That gives us 7, and we drop our 2. 1, 2, 3, 4 times. That gives us 60. 2 and 1. I will add, or no, my decimal's already there, so I add a 0 here and bring it down. And 15 can go inside of 120. 1, 2, 3, 4, 5, 6, 7, 8 times. So the cost of each pound of grapes was actually $2.48. So that's not too bad either. Alright, let's keep rolling. Okay, number 12. Here it says Dan has 141 action figures in his figure collection. 1/3 of those action figures are sports related. How many figures in Dan's collection are sports related? Whew. So, essentially, it's 141 times 1/3. When you do that, you're just going to end up with 141 over 3. So that's what we're going to end up doing. It's just dividing that by 3. And then that's our quotient is going to be how many figures in Dan's collection are going to be sports related. So this one's not so bad. 3 can go inside of 14 4 times. That's 12. 2, bring down the 1, 7, 21. So 47 of his sports figures, or of his action figures, are sports related. Number 13, it says the Grady family built a rectangular swimming pool in their backyard. Perfect. So rectangular swimming pool in their backyard. The floor of the pool has an area of 485 and 5/8 square feet. Cool. So we're working with area. Area is length times width. They've already given us an area. Pool has an area. And the width is 18 and 1/2. So for me, it's going to be easier if I turn my fractions here into decimals. 1/2 is easy because the width is just going to be 18.5. 1/2 is equivalent to 0.5. 5/8. All right, let's do that one. 5, 8, 0, decimal 0, and that goes in 6 times. Yes, this can continue, but we're not going to have that continue. Okay, we're just going to stop at the 0.6. So now on the inside of my rectangular pool, I'm writing 485.6. I'm doing that on the inside because that is that's what we cover when we're talking about area. Area is everything on the inside, okay? Perimeter is everything on the outside. So this is important because my area I already have. My width I already have. So that means I'm missing my length. And in order to find my area, I would have had to multiply. But if I have something here and I have my final answer, then what I'm actually going to do is divide. Okay? And we're going to divide, or no. Yeah, we're going to divide. I'm tripping, sorry. And so that's why it's important to turn this into a decimal and to turn this into a decimal, because dividing decimals is not that hard. So let's go ahead and set it up. We have our 485.6 divided by our 18.5. All right, here's that situation again where we have to turn our divisor into a whole number. So we slide our decimal there. We slide our decimal there. So now we really just have a bunch of, or now we're just messing with whole numbers, which is perfectly fine. So let's make a list here. We're going to start with 185, 370. We're going to say 555. We're going to say 740. 925. 1110. Let's do 1295. I guess we're good right there. If we have to go more, we can do more. But we're good there, and this is us skip counting by 185s. Okay? Whoop. So 185, let's see how many times 185 can fit inside of 485. It looks like twice. So that's going to give us twice. That'll give us 370. And we'll subtract. 5 minus nothing is 5. 8 minus 7 is 1. And 4 minus 3 is 1. And we bring down our 6. So how many times can 185 fit inside of 1,156? Looks like the closest we can get is here. So that's going to be 1, 2, 3, 4, 5, 6 times. That's going to give us 1,110. We'll subtract there. Decimal here. Add a 0. Bring it down. 460. Looks like we can fit in twice. Okay. That's going to be 370. That's going to be 390. 90, right? Add another 0, bring it down. 900, 1, 2, 3, 4, 4. I mean, we can stop right there. Well, I think what's going to happen is, fine, we'll keep going. This, okay, not a big deal. We'll keep going. Fine, not a big deal. Fine. You want to do that? We can do that. 8, 10, 0, 6, 1, and then another 0. Bring it down. 1,600. 1, 2, 3, 4, 5, 6, 7. Probably, looks like this is going to be like 8. So in this case, we're actually going to use this number to make this round up. So this is actually going to be 26.25. I'll say or 26 1/4. That's why sometimes with these decimals it's a little tricky. But ultimately that's what they're looking for. So let's look at 14. Shania has 8.75 gallons. Cool. And she wants to use 2/5 to paint her living room. How many gallons will she paint? Okay. So 3/4. We can do this 2 different ways. Let's turn our 2/5 into a decimal, okay? So we have 2 divided by 5. That can't work, so we do a 0. Decimal 0 goes into 20 4 times. All right, so I did that because I'm going to have us set up 8.75 times 0.4. Yeah, that's fine. 0.4. I mean, yeah, that's fine. Whatever. We can do that. All right, cool. Now we have, let's see, 1, 2, 3. So now we're just going to do 875 times 4. This is going to give us 20, 28, 30, 32, 35. And we move our decimal over. A 1, a 2, a 3. And so she's going to end up using 3.5 gallons of paint. All right. Here we're going to turn our fraction into a decimal as well. It says the winner of the raffle will receive 3/4 of the money raised from the raffle ticket sales. The raffle raised $530.40. How much money will the winner get of the raffle get? So here I'm going to set it up as 530.40 times. Again, we did this earlier, but 3/4 is really the same thing as 0.75. I'm doing this so that we can see how many digits are on the right. 1, 2, 3, 4 of our decimal. So that when we find our final product, we can move that decimal over. So we're going to have 500 30, and we're going to have 75. Cool. So it's going to be 53,040 times 75. So 5 times nothing is 0. 5 times 4 is 20. 5 times 0 is 0 plus 2 is 2. 5 times 3 is 15. And 5 times 5 plus 1 is 26. Cross out my 5, put a 0 underneath, scratch out what I carried, and I can start over. 7 times 0 is 7. 7 times 4 is 28. Put the 8 down, carry the 2. 7 times nothing is 0, plus 2 is 2. 7 times 3 is 21. Put the 2 down, put the 1 down, carry the 2. And 7 times 5 is 35, plus 2 is 37. And you add your partial products. We have 0, 0, 10, 8, 7, 9, 3. We move our decimal spot over 4 times. 1, 2, 3, 4. And the winner would end up getting $397.80. It's pretty good. All right, we're actually almost done. Okay. When we're looking at this one here, it's saying Suki has split 5 dog treats equally amongst her 6 dogs. So 5 dog treats equally among her 6 dogs. So if I'm writing that, I'm thinking of different ways to write it. I'm splitting up the 5 dog treats among 6 dogs. The 5 dog treats among 6 dogs, or the 5 dog treats among 6 dogs. That's how I should be immediately seeing and writing that. So now it's a matter of just finding what they're looking for. If I can be really truthful here, the 2 answer choices we can get rid of immediately are C and D. They didn't mention anything about 1 of anything, so we can get rid of that. Now here, 5 divided by 6 can also be written as 5 over 6. Our 5 dog treats split equally amongst our 6 dogs. The only one that matches here is B. A cannot be our answer. For 17, it's another multiplication question. It says Chris is buying 14.4 pounds of chicken to make a large casserole. The chicken is on sale for $1.60 per pound at the grocery store. How much would it cost Chris to purchase the chicken? Okay, so we're going to set it up as 14.4 times 1.60. We're going to look at how many digits are on the right of the decimal. 1, 2, 3. And then we just multiply. Yeah, all we're doing here is multiplying, so let's get that done. I'm going to do my 144 times 160. The first set of numbers is literally just zeros. So 0, 0, 0. Cross this out, and I put a 0 underneath to represent I've used my ones place. 6 times 4 is 24, carry the 2. 6 times 4 is 24 plus 2 is 26, carry the 2. 6 times 1 is 6 plus 2 is 8. Cross out my 6, scratch out what I carried. I put 2 zeros to represent I've used both my ones and my tens place. Then it's just 1 times everything. 4, 4, 1. Add your partial products. Should end up with 0, 4, 10, 12, 13, 2. You move your decimal place over 3 spots. You end up with 1, 2, 3, $23.04. All right. Okay, Mr. Parker gave 9 cookies to 5 children to share equally. How many cookies does each child get? Which expressions are equivalent to this? Okay, so again, he's giving 9 cookies to 5 children. So again, I'm immediately writing that all 3 ways I know. So let's say he's going to give 9 cookies and he's going to divide it by his 5 kids, right? He's going to take those 9 cookies and divide it by his 5 kids, and he's going to take those 9 cookies and divide it by the 5 kids. Perfect. So that's what it should look like. Let's see what we can find. Well, the first one matches what we have here, so that's going to be equivalent. That's a reciprocal. This means I have 1 1/4 or 1 4/5. This means I have less than 1. So I'm going to say no, that's not equivalent. 45 divided by 5 is just 9. Again, 9/5, if I decompose it, is the same thing as 5 over 5, which is 1, and 4 over 5. So 9 is not going to be equivalent to 1 4/5. 9 divided by 5, well again, that matches what I wrote earlier, so that will be equivalent. 5 divided by 9, no. They're not giving 5 cookies to 9 kids. They're giving 9 cookies to 5 kids. So that is not going to work. And the same thing we had here, 45 divided by 5, that is also not equivalent. So that's what that's going to look like. 19. Dividing a rational number is the same as, well, okay, when we divide rational numbers, right? Let's say we're going to do this. Well, remember, we keep, change, flip. So we keep this, we change that to multiplication, and we flip the other one. So dividing a rational number is the same as multiplying, because that's literally what we're doing. Now, when we flip this, that's actually called the reciprocal. Absolute value is the distance from 0, and the opposite of 1/3 would be negative 1/3. Those are opposites, okay? Those are not reciprocals. Reciprocals is just different, it's just our fractions flipped. 5/8, the reciprocal would be 8/5. 2/3, the reciprocal would be 3/2. Okay? So that's what we're doing when we're actually dividing fractions. A fraction is a rational number. Is we keep, we change, we flip. So we actually end up multiplying the reciprocal. Alright, this is going to be our final one. So let's get into it. So it says, which of the following expressions has a product less than 4? So what we multiply has to be less than 4. And we have to choose 2 different answers. So let's work with this first one. We have 4 over 1 times, what is it, 2 and 1/2. Let's walk around Texas. So really what we have now is 4 over 1 times 2 is 4 plus 1 is 5. 5 over 2, which is 20 over 2, which is the same as what, 10? Is 10 less than 4? No. That's why it does not work. Here we have 4 over 1 times 5 over 9. We multiply straight across. We get 20 over 9. 9 can go into 20 twice. 2 times 9 is 18. 20 minus 18 is 2. 2 and 2/9. That is less than 4. So that works. I have all this space, so let's go ahead and use it. Let's do the next one. We'll do 4 times 1, or over 1 rather, times 3 over 2. I could actually do a partial product here. 2 goes to itself once, 2 goes to 4 twice. So this will actually just give me 6, and 6 is greater than 4, so we can't use that one. We're going to talk about this one next. 4 over 1 times 6 over 4. Again, partial product is 4, or common factor rather is 4. Goes into itself once, goes into itself once, multiply straight across. You also get 6. 6 is greater than 4. So we can't use that. Our very last answer choice is 4 over 1 times 2 over 3. That's going to be 8 over 3. Let's see. If we decompose that, we can go 3 over 3. That's 1 whole. Another 3 over 3. That's 2 wholes. 3, 6. And what's left is going to be that 2 over 3. So ultimately what we have here is 2 2/3. 2 2/3 is less than 4. So it works. Woof! And that's our CBA 3 review, y'all. Good luck. Good luck, good luck, good luck. You guys can do it.